right, welcome back. And today we are going to work on our mid-chapter checkpoint, and then we're also going to go on to 12.5. So our mid-chapter checkpoint, we're going to review some vocabulary before we move on. So hopefully you have your book out and you're opened up to page 721 in your book, and you have a pencil. Remember, we don't do math in pen. So our mid-chapter checkpoint, our vocabulary words are over here on the right-hand side. We have angle, point, polygon, and right angle. So we're just going to go through this quickly since it's just a little bit of a review. So it says choose the best term for the box to complete the sentence. So we're going to read the sentences and then choose the correct vocabulary word. So an blank is formed by two rays that share an endpoint. Well, first of all, they give it away by having the word "and," because we know we can't use the word "a" if the next word is going to start with a vowel. So they use the word "and." So if you look over here, just using the context clues, we see A, P, P, R. So the only one that would fit here would be angle. But we also want to think about what an angle is. So it's formed by two rays, and we know when we have a line and we have a line segment and they come together at a point, that forms an angle. It says a blank is a closed plane shape made up of line segments. So hopefully you're thinking about, it didn't say any curves or anything like that. And so our only choice here would be point, which is just the end, like a period. Right angle, which are two line segments that come together and form an angle, and it's a 90-degree angle, or a polygon. So polygon would be correct. It's not a plane figure because plane figures can have curves and be opened or closed. This says a closed plane shape. And then our last one is a blank forms a square corner, and we know a right angle forms a 90-degree corner. So we're going to move on to our concepts, and it says to use the corner of a sheet of paper to tell whether an angle is a right angle, which has a little square in the corner, is less than a right angle, which is an acute angle, so it's inside of a right angle, or greater than a right angle, which is an obtuse angle. So take a moment, pause the video, and go through and decide 4, 5, and 6 and what kind of angle they are. Okay, so you can tell that this is a right angle, and you can see that because if you were to draw an L shape that would go up, you would see that this angle is inside of a 90-degree angle. So that's an acute angle. Right here, you can see the angle is a 90-degree angle because they put a little 90-degree box. And then right here, this one, right here, so you want to kind of turn it a little bit. So that one is greater than a right angle. So a right angle would be just about like that. So this is slightly outside, so that's an obtuse angle. Those ones are really hard. Hopefully you turned your book. All right, I can't turn my laptop, but you guys are able to turn your book and make it into an L, just like right here, an upside down L. If you can make it into an L or the corner of a square, then you have a right angle, and then this would be outside the right angle. They're very tricky, some of them. You have to be very careful. Number 7, 8, and 9, the directions say, write the number of sides and the number of angles, then name the polygon. So this is where we're going to count the sides. So we're going to first count 1, 2, 3, 4, 5, 6. So we have 6 sides. So you're going to write the number 6 and then count the angles. 1, 2, 3, 4, 5. Oops, did I mess up somewhere? Oops, 6. There's our 6. I forgot the middle one there. So you have 6 sides and 6 angles. 6 has an X in it, so that is a hexagon. We go over here. Oh, look at this one. This one's cool. I love shapes. All right, so if we draw this out, starting here, and we draw this line segment out right here, and we draw a little handy guy right there, hi, then that would be your trapezoid. So that's not what it's asking. So we have to go back to what it's actually asking for. So it asks for sides, 1, 2, 3, 4 sides, and then how many angles? 1, 2, 3, 4, and it has 4 angles, and then it asks for the name of it, and that would be a trapezoid. So next we go to sides, 1, 2, 3, 4, 5. We have 5 sides, and we have 1, 2, 3, 4, 5 angles, because that's where the line segments come together to form an angle. So 5 sides and 5 angles. Think about a 5-sided figure. Think about that amazing building that we looked at in September, and that would be the Pentagon, and that is a 5-sided shape. So that is your Pentagon. All right, so we're moving on. And we have that Anne drew the shape at the right. Is her shape an open or closed shape? Hopefully you know that all those line segments form angles, so that is a closed shape. Number 11, the sign right here tells driver that there's a steep hill ahead. Write the number of sides and the number of angles, the shape and sign, the shape of the sign, and name the shape. So hopefully you're counting 1, 2, 3, 4 sides, 1, 2, 3, 4, and you'll notice that has 4 sides and 4 angles, so that is a quadrilateral, and it looks like all the sides are the same, so that would actually be a square. Why is this closed shape not a polygon? It is closed. It is definitely a closed shape, except for it cannot be a polygon because it breaks the rule. It has curves. All right, number 13. Sean drew a shape with 2 fewer sides than an octagon. So think about an octa and what octa means, like octopus and how many legs an octopus have. Then think of an octagon, and the root word means 8. So if you draw a shape with 2 fewer, so that would be 8 minus 2, and then the shape would be 6-sided, so it would be a hexagon because they have the X. Number 14, John drew a polygon with 2 line segments that meet to form a right angle. Circle the word that describes the line segment, and hopefully you see that yes, if they draw a right angle, okay, there would be your right angle. 2 line segments that meet, there's where they meet. They would be intersecting for sure, but they have a very special name because they have a right angle, and that would be perpendicular. And that was yesterday's lesson. So hopefully you remembered those, and we are going to move on to chapter 12.5. So I hope you guys turned in your books. I'm going to turn in my book. So you guys are on page 723 now. All right, so we are classifying quadrilaterals. Quad, hopefully you're looking at the root word, thinking of quarters. There are 4 quarters in $1, there are 4 quarters in an hour, and then there are 4 angles and 4 lines in a quadrilateral. So how can you use sides and angles to help you describe quadrilaterals? There are lots of different kinds of quadrilaterals. So we're going to look at some quadrilaterals and name them by their sides and their angles. Okay, so describe the quadrilaterals. Quadrilaterals have to have, hopefully everyone knows that they have to have 4 sides and 4 angles. Now there is an error here. Some quadrilaterals cannot be classified as a trapezoid, rectangle, square, or rhombus. Okay, some quadrilaterals cannot be classified. Okay, so we're going to look right here. 1, 2, 3, 4, 4 lines. 1, 2, 3, 4 angles. Okay. Now this is a quadrilateral. 1, 2, 3, 4. 1, 2, 3, 4. 4 lines, 4 angles. Go through and count your angles and your lines. And you'll notice all of those have 4 lines and 4 angles, 4 sides. All right, so now a trapezoid. Trapezoids are very interesting. So a trapezoid would be right here. Okay, so it says at least blank pair of opposite sides that are parallel lengths of the sides that could be the same. So if you look right here and right here, those would be, let me get a color here so you can see it. So you'll notice right here and right here. Those are the parallel lines, and it has one set of parallel lines. Then if you go here and you go here, it has one set of parallel lines. Okay, trapezoid, at least one pair of opposite sides that are parallel lengths of sides that could be the same. Now, they are saying in this book, okay, that a square can be a trapezoid. When we think of trapezoids, most of the time though, I want you to see that they trap. So if we extend these out, and this is the way I'm going to be talking about trapezoids, they extend out. But we know a rectangle can be a square, but a square can be a rectangle, but a rectangle is not a square. A square has all 4 sides the same. All right, so let's keep going here. Oh, here's my other rectangle, or my trapezoid. So if I extend these ones out, you can see they cross over. All right, so they have to have at least one pair of opposite sides that are parallel, and I showed you one side that are parallel. You see these have 2, but it says at least, the word at least one pair of opposite sides that are parallel. So that's why the square also can be a trapezoid. Okay? Squares can be certain things, but then other things can't be a square. Like a trapezoid cannot be a square. We can see that. Okay? Because squares have to have, okay, certain characteristics, whereas a trapezoid, the square can fall into the trapezoid category. All right, so we're going to go down here. So here's our square can be a rectangle, but this rectangle cannot be a square. Okay, so remember, there are certain rules where a square can fall into something else, but they cannot fall into a square. All right, so we have rectangles. So let's look at the rectangles. Blank pairs of opposite sides that are parallel. So this, there's one set, and there's 2 sets. 2 pairs of opposite sides are parallel. So you're going to write 2. Oops, I'll just have to make 2. And then you have 2 pairs of sides that are of equal length. There's one side that's equal length. There's 2 sides that are equal length. So there's your 2 sides. And then it does have 4 right angles, which you can see. Go to a square. It has 2 pairs of opposite sides that are parallel. 1, 2, and then 2 pairs that are equal length. Absolutely, all 4 are equal length. And then it has 4 right angles. Now a rhombus, here's that strange thing again, okay? So you have 2 opposite sides that are parallel, and you can see that. And then you have 4 sides that are equal length. Equal length, equal length, equal length, equal length. A rhombus is not a square because it does not have, okay, right here, do you see this? Okay, a square can be a rhombus, but a rhombus cannot be a square because squares have to have 90-degree angles. And you can see that right there. You had to have 4 right angles. Okay? All right, so we're on to our Sharon's show. So let me pull up your video. See if I can get this worked out for you.
Oh, hi, sorry. I was looking at myself in the mirror. Actually, you know, this reminds me, though, of a fun riddle where I tell you who I am, and you have to guess who I am. So let's see if we can figure this out for ourselves. I am a polygon that has 4 sides and 4 angles, and at least one of my angles is less than a right angle. Our challenge is to circle all the shapes that I could be, and no cheating by looking in the mirror, like I was just doing. Okay, so let me show you all the candidates that we're going to look at the circle. Ready? Bring on the candidates. Okay, everyone, slow down. Okay, so quadrilateral, rectangle, square, rhombus, and trapezoid. Okay, so I am a polygon that has 4 sides and 4 angles, and at least one of my angles is less than a right angle. And the question is, which of these could I be? All right, quadrilateral. What does that mean? Well, that's a polygon, which means a closed shape that has only a straight line edges, so edges made out of line segments that are attached at their vertices, at their endpoints. And a quadrilateral, quad is actually a secret code for 4, so it means it's a polygon with 4 sides. So something like these might actually be examples. So any of these are quadrilaterals because they're all closed. They're all made with line segments that meet up just at their endpoints. And check it out. They all have 4 sides. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So these are polygons with 4 sides and 4 angles. Now, is it possible to have one of these that has at least one angle that is less than a right angle? Remember, the right angle ones are the ones where they're perpendicular to each other. So they kind of look like these. These are all right angles. So this is an example. This looks like a rectangle, doesn't it? Where all the angles are actually equal to right angles. So none of these are less than. But what about these? Well, check it out. This is a very tiny angle. That looks a lot smaller than a right angle. And in fact, if you look at this one here, this is a very tiny angle. Looks like a lot smaller than. So these are examples where we could have a quadrilateral that actually has at least one angle that's less than a right angle. So a quadrilateral is one possible shape where, in fact, you could actually have that, because here's some examples. Not all of them, but at least there's some. So the answer is yes. So I could be a quadrilateral. I could be a quadrilateral. Boop. Now, what about a rectangle? Could I be a rectangle? Well, you know what rectangles look like. They're quadrilaterals, which means that they have 4 sides, and each side, of course, is made up of a line segment. They meet up at their endpoints, and we know that the opposite sides are going to have equal length. Opposite sides are going to also be parallel to each other, and we know that every single angle will be a right angle. This is a very special example of a rectangle. This one is, in fact, a square. This is a rectangle where both the length and the width, in fact, are going to have the exact same measurement. So the length here and the length here are, in fact, the same. And that's a square. So square and rectangle, they have the properties that their opposite sides are parallel to each other. Opposite sides have the same length, and every single one of their 4 angles is a right angle. So is it possible to have at least one angle less than a right angle? No. So a rectangle, in fact, is not a possibility. There's no way I can have a rectangle. Even though it has 4 sides and 4 angles, we will never have at least one angle less than a right angle. And the same thing with the square. So these two will not be circled. Those are not possibilities for who I could be. I am not a rectangle, and I am not square. Now, what about a rhombus? Well, now we're talking. talking. A rhombus. A rhombus is a very interesting type of a shape because it is a quadrilateral. It has four sides and four angles, and it has the property that opposite sides are parallel. And in fact, all the sides have the exact same length. So the length of this is equal to the length of that, equal to the length of that, and length of that. Just like, for example, with a square. So a square is an example of a rhombus. Parallel, opposite sides parallel, opposite sides parallel. Everyone has the same length, and that means it's a rhombus. Now notice that with a square, we've already said that every single angle is a right angle. So we know that with a square, all of these angles are right angles. So in fact, we know that a square will never have at least one angle less than a right angle. But check it out. This one, this particular rhombus, it does have an angle that actually looks like it's smaller than a right angle. So this is less than a right angle. So it's possible. It's possible that actually I might be a rhombus. That's right, I might be a rhombus. Because we could have a rhombus. All rhombi have four sides and four angles, and you could imagine a rhombus that has at least one angle that is less than a right angle, and there's an example of one. So it's possible. So that's kind of cool. And then finally, what about a trapezoid? Well, a trapezoid. Bim, 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 a trapezoid. So here are examples of trapezoids. They are quadrilateral, so they have four sides made out of line segments. And here, you must have exactly one pair of opposite sides that are parallel. And the other two sides have to be not parallel. So check it out. Parallel, not parallel. Parallel, not parallel. So if we have that, then we call it a trapezoid. So a trapezoid is a quadrilateral where there is exactly one pair of opposite sides that are parallel, and the other two pair are not parallel. So if we look at this, is it possible that we could have a trapezoid that actually satisfies all these conditions? Well, let's think about it for a second. All trapezoids have four sides and four angles, so that's great. And is it possible that at least one angle is less than a right angle? Sure, in my picture, that angle looks like it's less than a right angle. And in this picture, it looks like this angle is actually a little bit less than a right angle. So the answer is yes, I could be a trapezoid. So we were asked to circle all the possibilities of what I could be, given that I'm a polygon with four sides and four angles with at least one angle less than a right angle. And it turns out there are a few possibilities. I might be a quadrilateral. I might be a rhombus. I might be a trapezoid. In fact, all of these are possible, and in fact, I'm definitely going to be a quadrilateral, but it's not quite clear if I'm going to be a rhombus or a trapezoid or just some lone little quadrilateral. Anyway, it's great to figure out what I am, and of course, one way to know what I am is, of course, just to look at me. Woo.
In my hand.
There I am.
Who's the
Math,
greatest
mirror, mirror,
math person?
in my hand, who's the greatest math person in the land? Hold on one second. It said me. Trust me. Have fun thinking about math.
All right, so we are back and we are going to look at the quadrilaterals at the right. Hopefully everyone is on page 724. So if you look at the right here, you can see that you have four sides that are right, or four angles that are right angles, and you see four parallel sides. So outline each pair of opposite sides that are parallel with a different color. So we're going to go over here and we're going to get some different colors, and we'll do the opposite sides. So there's our first one, and then we'll go to green and we'll look at this one, and we'll draw our opposites. So outline each pair of opposite sides that are parallel with different colors. How many pairs of opposite sides appear to be parallel? Hopefully you're seeing two different sides. Look at the parallel sides you color. The sides in each pair are equal length. Okay, so equal, 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 and equal. All right, so this these are not the exact same length as these. You can see that. So name the quadrilateral in as many ways as you can. We would say this was a rectangle, but it also can be qualified as a trapezoid, which we saw in the last page that we looked at. But we definitely would call this because the opposite sides are the same length. Not all four, just the opposite. All right, so we're going to go down below and it says circle all the words that describe each quadrilateral. Quad means four, so all of these shapes have four sides. So look at this. Think about what it would be. Okay, so hopefully you are seeing that it is a rectangle for sure, and it could also be a trapezoid, which we just talked about. Over here, this right here, it looks like a diamond, so it would be a rhombus and also a quadrilateral because anything with four sides is a quadrilateral. Now this one, if we extended it out and we extended it out, they would intersect. So it would be a trapezoid, and for sure it has four sides and four angles, so it would be a quadrilateral. And it says on your own, circle all the words that describe the quadrilateral. So hopefully you're pausing and you are thinking about all the words that describe this quadrilateral. So just pause and do that. All right, hopefully you came up with for this one that it is a quadrilateral. It does not fall into any of the other categories. This one would be a trapezoid, and this one would definitely be a quadrilateral. It is a square, it is a rectangle, and it is a rhombus. How can you have a rhombus that is not a square? And a rhombus has four sides with four equal lengths like a square, but a rhombus may not have four right angles like a square. Okay? So squares have to have right angles. All right, so we're going to go on to our problem-solving application. So turn the page, and it says use the quadrilaterals at the right to answer 10 through 12. Which quadrilaterals appear to have four right angles? So remember, a right angle is where you can add the little square where two line segments meet to form an angle that is exactly like an L shaped or the corner of your paper. So hopefully you are seeing that B and you are seeing C. Okay? Which quadrilaterals appear to have two pairs of opposite sides that are parallel? Hopefully you are seeing, so this one is, which quadrilaterals appear to have two pairs of opposite sides that are parallel? That would be definitely B again, definitely C again, and then hopefully you added D because they would not intersect. Which quadrilaterals appear to have no right angles? No right angles. So I'm going to go with something a little bright so you can see it. Hopefully you've gone through. So if you look at D, no right angles, does not form any L's. E is a trapezoid and it has acute and it has obtuse angles. And then F, this has an obtuse and these are acute angles, no right angles. Okay, write all or some to complete the sentence. So number 13 says, the opposite side of blank rectangles are parallel. So hopefully you see a rectangle, all sides are parallel. Okay, number 14, blank sides of a rhombus are the same length. Now we talked about that, and we know that all sides of a rhombus are the same length. It's like a square, but it's not. But it has some of the same qualifications as a square, but a rhombus does not have right angles. Number 15, blank squares are rectangles. All squares are rectangles, but rectangles are not squares. Number 16, blank rhombuses are squares. All rhombuses are squares. Number 17, blank quadrilaterals are polygons. All quadrilaterals are polygons because they all have line segments that are closed. And then polygons are quadrilaterals. Well, now that only some polygons are quadrilaterals because you could have a polygon that is a hexagon or an octagon or a nonagon or a dodecagon or triangle. So not all polygons, only some polygons are quadrilaterals. Then you have number 19. And it says circle the shape at the right that is not a quadrilateral. So you go over and you find that is not a quadrilateral, you count them all, and then you look right here and you see that that has 1, 2, 3, 4, 5. A 5-sided figure is, hopefully you know what that is, a pentagon. And number 20, I am a polygon that has 4 sides and 4 angles. At least one of my angles is less than a right angle. Circle all the shapes that I could be. We went over that. We learned that they could be a quadrilateral, they could be a rhombus, and they could be a trapezoid because it says at least one of my angles is less than a right angle, and we know that rectangles and squares have all 4 right angles, so they could not be classified as that polygon. So we're going to, if you want to do this on your own, you can for some extra work. Right now you are going to pause the video and do your practice and homework and your lesson check, and then you're going to come back and unpause me and you're going to check your answers. So pause, do the work, and then come back. All right, so if you are back, you are ready for your answers. All right. So it says circle all the words that describe the quadrilateral. Number 1 is done for you. Number 2, you see all 4 right angles, 2 sides are the same length and the other 2 sides. So we know that that is a rectangle, and that could also be a trapezoid. We usually don't say that as a trapezoid, but it could be classified as a trapezoid also. Over here, this is usually what we see. So we see that it would be a trapezoid where if you extended these lines out and up, it would trap right here. Okay, number 4 is B, D, and E. Number 5, A and C. And number 6, B, C, and D. Number 7 is a square. And number 8 says explain how a trapezoid and a rectangle are different. A rectangle has 2 pairs of parallel lines where a trapezoid only has 1 pair of parallel lines. Okay, we're going to move on. Our lesson check, the word that describes this would be a trapezoid because you could extend this down and see that a little man was trapped down here. Number 2 would be A and B. 3 is a decagon. We have 2 pairs of parallel lines. 5 is a parallel. Okay, parallel. Right here, every single side is parallel. And then how many right angles does this have? It has 0 right angles. Okay, those are acute, acute. This would be obtuse and obtuse. All right, I hope you had a really great math lesson today, and I look forward to seeing you tomorrow. Take care.